Oh, hello, hello. What's the thing all the YouTubers say? Hello, boys and girls? Hello, ladies and gentlemen. Today on Let's Play. Let me actually pull this page over real quick here. We'll finish getting our stuff ready. And then we'll go. And this will be Ammon's awesome workshop for database foundations. Anybody that's watched my previous workshops may or may not have noticed that I have gotten rid of a majority of my beard. I'm starting to get kind of long. Maybe it's time to let it regrow and redo. I guess one of those things where if it starts going wonky, turn it on and off again. All right, let me share my desktop here so I can see what I can see. And what I am going to do today for this workshop is I'm going to go through the basics of getting started in NoSQL, right? I'm going to step through lesson 1 in our LMS portal, right? Get everything installed, get everything set up, everything you need to get going and get started in our database foundations class. First things first, necessary software, right? We're going to be using SQLite for this course. That means that we don't really need a database engine sitting behind it. The single file is the database engine. SQLite is a portable database technology, which is pretty handy. It's used all over the place. It's very common in mobile applications, Android in particular, I believe, because it is a single file. It doesn't take other resources and memory and storage to get started with it. You deploy something, you have a file with it, bam, you got a database. There are pros and cons with SQLite versus other database technologies, but we'll cover that kind of stuff a little bit later. Maybe some future workshops to show this kind of thing. All right, so first things first, if we choose to go the SQLectron route, then we need to download it. The link is on the second section of getting started with SQL. For anybody trying to make sure they pronounce this correctly, it's either SQL is an acronym or SQL. I don't ever think I've heard it SQL, maybe, who knows, but SQL or SQL. All right, download the GUI version of SQLectron. Right. SQLectron is an Electron-based application. If anybody is not familiar with Electron, Electron is what Visual Studio Code is based off of as well. That means it's portable and very easy to set up. It actually does not require an installation, depending on your platform. All right, sure. So we're going to hit this download GUI button. Version 1.30.0, September 5th. All right. What we want is depending on your platform, right? For Macs, we have a DMG, or we have a Mac.zip. For Windows, we have a Win.7zip or Win.zip. Me, I'm going to open up the Win.zip file, 67 megabytes. We can kind of see the compression difference too between 7zip and WinZip. All right. This should finish in just a second. Almost. It's flashing at me. There we go. So what I want to do is I want to open this guy up. This opens up all these options here, right? So I'm going to minimize everything until I can see my desktop. I'm going to open up my downloads folder, pull it to the side first to make sure I don't have anything inappropriate in there. Get rid of some of this other junk. Basically, I have this file on my downloads right now. I'm going to take this file and I'm going to push it onto my desktop. It's right here. Right. I'm going to open it up. Actually, no, I want to right-click on it. I want to do, that's the 7zip options. I do want to open it up. And make a new folder on my desktop. I'm going to call this SQLectron. So I have my zip file, and I have SQLectron, right? I'm going to take all these files inside of here, and I want to extract them into this folder. I can drag and drop them in. It's going to take a second. Bam, we're done. Step 1, download. Step 2, move to your desktop. Step 3, new folder. Step 4, extract it to that folder. Right? So I can open up this SQLectron folder, and inside here there is a SQLectron.exe that I'm going to double click on. Awesome. I am ready to go. I have other databases in here. I'm going to remove those real quick. It remembers these databases at a system level. Remove. All right. So here I am, SQLectron, right? But I need a database. So what I'm going to do is I'm going to hop back to my Chrome browser. I'm going to go back to my lesson. I'm going to scroll down until I see download and open the sample database. It's going to say next, download this sample database. It's going to be chinook.zip. If I click on that, it should open up chinook.zip. Right? I can show in the folder. It's going to show me chinook.zip. Right? For my own personal preference, I generally make a databases folder on my desktop. So I kind of have these things grouped together. I'm going to open up chinook.zip. It shows me the chinook.db file. I'm going to throw that in my databases file. Verify that by opening up the databases folder, chinook.db. And I'm ready to open up that database inside of SQLectron. I can press the Add button at the top right, or I can say File, no, maybe Servers, no, and it looks like. Name, Chinook, database type, SQLite. The only other option I need is this initial database key space option. I'm going to browse for this file. So I'll go to my desktop, see databases, and chinook.db. I'm going to open it. I'm going to press the test button. Connection test. Successfully connected. Save. It brings me back to this window. I see my database listed here. When I press connect, this will connect me to my Chinook database. Memory size 0. Cool. All right. I can see several things here. I have some sort of a text editor on the right-hand side of the screen. Increase the text a little bit. I have a listing of things on the left-hand side. I have some buttons. I have some pretty interesting things on here. It also tells me where this database file is located. I can open up new tabs, and I can close tabs. I want to save a tab. I can say, can I right-click? No. File, save query. It allows me to save a tab as a SQL file. On the left-hand side, we have tables. I can kind of poke around and explore a little bit and see some things in here. Right? I see I have all sorts of stuff in here. So the left-hand side of the screen is the tables that are in my database. The right-hand side is my query editor. I can type my SQL in here. I can press the execute button. I can also press Control-Enter or Control-R as a shortcut. So if I type something in here, Control-Enter, it will execute. Or I can just press the execute button or Control-R, short for run. I'm going to close this tab here. What can I do? Increase and decreasing of text size is Control- and Control+, at least on Windows. And we can have a wrap content check option. I can make this section bigger too if I want to. Give myself a little bit more room, right? Give yourself plenty of room to work with queries. They can get kind of complicated, right? This is path 1. Right? If for any reason SQLectron is not able to work on your system, there is a plan B. Plan B is using something called DB browser. Right. Let me find out where actually that page is. Yep, that was it. This is accessible at the website SQLitebrowser.org. That's SQLite browser.org. We have several options here as well. On Windows, so I'm going to choose the Windows 64-bit EXE. I'm going to select this, and it's going to give me an installer. I'm going to install this app real quick. I'm going to choose, so far, just the default options and install. Awesome. I'm going to run it. Cool. It's right over here. It loaded up. At the top, we have an Open Database button. I can open Database. I can go to my Databases folder. I can open up my Chinook database. Right? We're going to see this looks a little bit different in SQLectron. Instead of different sections of the page, I have I still have sections. I have an Execute SQL section. I have my tables on the right-hand side. But generally, I have access to the same types of information, and I can do the same things. I can run the same query. Select star from albums. And Control-Enter as well will execute that query. It's a handy shortcut to know. And here's my data. I can see that compared to SQLectron. Where's my, oops, down below there. All right. I can see I get generally the same type of experience. Right? I get some sort of rows returned and data. So I'm able to access my database and browse through it and execute my queries. Right? I would highly recommend in any of these systems always saving your queries. Right? My Execute SQL gives me a save button here. And SQLectron will be able to say File, Save Query. I could save it as maybe first query.sql. If I open up my desktop databases folder, I'll see first query.sql. If I were to browse inside of there, I would see, and there's my query. Cool. So I would always save your queries. Right? Step number one, always back up your data. Create yourself something that allows you to continue working and not lose work. Just don't forget to save your files often. Right? Cool. So either of these applications will produce the same results with the same queries and the same output, but they go about it through a different interface. Right? Pick one and stick with it. If one doesn't work, these are two compatible programs, or comparable programs. They both accomplish the same goal. I'm going to stick with SQLectron because that is the view that's listed in our portal. Right? All of our examples are going to be based off of SQLectron. Right? Cool. We can see we went through most of this information already. We connected. Right? Chinook.db. We're already on section 4. There's all sorts of stuff in getting started with SQL. Right? So let's talk about SQL a little bit. Right? I don't want to go through and parrot all of this information. What I want to do is talk a little bit about just databases in general. Right? A database is like an Excel worksheet, if you've ever worked with Excel. It's a table of data. Right? A table consists of rows and columns spread throughout this table. For example, this albums table has 347 rows and 3 columns. I can see those rows and columns of data if I select data from this table. Right? All sorts of data. Okay. I can also see a list of artists if I select from the artist table. Cool. So I can see that each of these tables is kind of named after what it deals with. Right? I have an albums table. Be an interesting night. I have an albums table, an artist table, customers, employees, genres. I got playlists and tracks. I have invoices and playlist tracks. Some of these names get a little bit more complicated. In general, though, each one is built to hold that particular type of data. If I have information about an album, it will go in my albums table. If I have information about artists, it will go in the artists table. Customers, the customer table, and so forth. The main goal of databases, or one of the goals, is to keep data easy to access. Easy to access and granular at the same time. Just like when we're building classes or objects in our programming languages, we want to deal with databases the same general way. We want to group together as much data about one single entity as possible. But when we start repeating ourselves or duplicating information, that's a great indicator for maybe there should be two tables, right? If I'm listing out my name, my address, and all of my favorite movies all in one row of data, maybe those should be separate things. My name is in one table, my address is in a table of addresses, my favorite movies is in a table of movies. Right? Those can be many different things. So all these are kind of my nouns. They're my descriptive objects. These are my tables. Tables are king in SQL because they hold all of our data. Not only do our tables hold data individually, but they have relationships between each other. Right? A lot of databases in SQL are referred to as relational databases. Right? It's not just a table by itself. They have relationships. This Chinook database just so happens to be the sample database for SQLite itself. Howdy. How's it going? All right. So, where did that go? No, check. Pulling something up real quick here. Here we go, cool. There is actually a diagram for this SQLite database. Right? I'll pull it up here. Diagram. Cool. This diagram illustrates the color. There we go. The relationships and tables that are in this Chinook database. Right? If you do not have this diagram or access to any of this, I would highly recommend it. I just searched for SQLite database Chinook diagram, I believe. If not, I'll keep this link up for just a second. So if anybody wants to copy it, use it. So this illustrates that all of our tables have some sort of crazy relationship. There's all sorts of arcane symbols and diagrams and things between them. I can kind of take my finger and trace from one to the other, and to the other, and to the other, or all over the place. Right? This data starts to be richly complicated, which is pretty cool. Right. Groovy. So kind of a quick rundown of kind of the gist of what a database is for. Right. So let's talk about what's next for databases. Let's just learn some basic querying. Right. Some basic querying. So the first thing we want to do is be able to read data. I want to be able to read data out of these tables. I want to be able to explore this system. Right? I want to see what's in here. Right? I need to do something real quick here. Video. Cool. I want to be able to see what's in this system. Right? So the way to do that is by a select query. My personal preference is to write all of my SQL keywords in capital letters. All right, so then I'm going to go ahead and write a first basic query. Say select. Right. Select says, give me some data. Right. Select. What do I want to select? I want to select everything. An asterisk is shorthand for all columns. Right. I select columns from a table. So give me all of them. Right. From. Tells me where I get my data from, and my table name. Right? So get columns from table. kind of what we're trying to accomplish here. Give me columns from table. If I run this, it gives me all of the information from my albums table. Album ID, my titles, my artist ID. It gives me just everything from there. So select star from albums. Give me data from this table. Instead of albums, I could say artists. Here's my artists. I can pick any table that I have in my list. Tracks. Data from tracks. But that was going to take a second longer because it is a bigger table. 3503 items. Right. So give me columns from table. What if I don't want all of the columns? I can see here there's 4, 5, 6, 7, 9 columns here. But if I don't want all of them, this is a lot of data. Right? Instead of an asterisk, I can say what columns I want, and I call them out by name. Say I want the name column, and I want the composer, and I want the milliseconds. Execute that, it should give me those 3 columns only. I get name, composer, and milliseconds. Okay. So I can either use column names directly, or I can use an asterisk as a wildcard for give me all columns. I can use one, or I can use the other. I can't use both. It might let me, but it's going to go a little bit weird. It's going to give me all the columns, and I think it's going to duplicate. Or it's going to give me an error message. 50-50. Okay. Apparently it did neither. It just ignored everything I gave it. It gave me everything anyway. Generally, it's you either see an asterisk or you see specified columns. Put them in any order I so choose. They don't have to be in the order they show up in the table, which is kind of handy. Maybe we want to reorder some of the data a little bit. Right. So the select keyword and the from keyword, select says what I want, and from says where I want to get it from. Right. I always want to end my queries with a semicolon. Just like in our regular programming, semicolons tell us when we are done executing a line of code. I can then write another query. Maybe I wanted select star from artists. Execute this, it will give me both of the results. It'll give me the first table of results set as query 1, and the second table of results set as query 2. It'll run both of my queries, one after the other. If I don't have my semicolons, it's going to give me a problem. It's going to say there's an error near select. Typically, this kind of generic error near select, means I've missed a semicolon somewhere. Right? If I only have one query, the semicolon is not necessary because there's only one thing to run. And one of those things where you don't need it, but it's a good habit to get into, just in case. Right? Say I wanted to comment something out. 2 dashes in SQL will generally comment things out. So I can keep queries handy. I can comment ones out and uncomment some others, kind of like normal code. Right? SQL is still a programming language. Bring my notes up on this lesson to make sure I'm not going too far. So select, right? Select is pretty cool. It tells us where we can get data from and what data we want. Select columns from table. Right? I'm going to start that off the top. Select columns from table. I just replace what columns I want and the table name that I want. Pretty straightforward. So I've already found out that if I don't want all the columns, I can specify the names of some columns. But what if I don't want all of the rows? That's where our next keyword comes in. I'm going to say select star from albums where. I'm going to say album ID greater than 10. Execute this. You'll notice that my album IDs start at 11 and go down from there, or up from there. So this was kind of the query I had before. And this time I'm adding a filter onto this query. My where condition is generally what my filter is going to be. I have some sort of a true-false condition I can apply to every single row in this table. It's going to go row by row and say, hey, is your album ID, which is the name of the column, greater than 10? If it is, give it to me. What if I wanted to include the 10? I could do greater than or equal to. It's going to include the 10. Right? I have all of my equality operators here. I have greater thans and less thans. I have equal to. Say, give me the album ID where it's equal to. Give me the album where it's not equal to 10. It's going to give me everything but 10. There's a gap of 10 right there. I go from 9 to 11. So all of my equality operators are still here, just as though I was making an if condition. You can kind of imagine that the same way too. Picture you're writing a for loop, and you're going through one by one for your rows. You want to have some sort of a test on whether or not you want that row. Right? This is our true-false condition that tells us if we want this row or if we don't want this row. Right? We can imagine if our tracks table, like we saw, had 3,500 rows. What if I only wanted 3 or 4 things out of there? I could probably get pretty specific on what data I want. Right? So my where column equals value. I can then add a second line onto what my queries look like. So I select columns from table, and then optionally, I can say where column equals value, or some sort of true or false. Some sort of true or false. A little bar right here. Slanted. Okay. Some sort of condition that tells me if I want to get these rows or not. And I can combine them together. Give me the title from albums where the album ID is not equal to 10. Ooh, there we go. Just my data. Right? So I can drill this down pretty specifically. I can slice and kind of compile my data in just the data I want to look at per table. Right? What if I wanted multiple conditions? What if I wanted to say, give me where the album ID is greater than 10, or where the album ID is less than 6. I want it where it's greater than 10 or less than 6. So 6, 7, 8, 9, 10 should not be in this list, right? Star. I'm bringing all my columns so I can check that. Or is it going to give me those at the end? It's a good question. It will. So I have 1, 2, 3, 4, 5. Those are all less than 6. And then at the very top, I start from 11. It's pretty neat. If I did this the opposite direction, I said less than 6 first, and greater than 10. This will give me the 1 through 5 first. It's going to go one by one and apply this condition to the whole thing, apply that condition to the whole thing, with an or. It meets either of those conditions. So I have ors and I have ands. Right? I have my general logical operators. An and. If I do an and here, nothing will match. Nothing is less than 6 and greater than 10. So or is the only one that will work in this condition. I can keep on stacking those. Or title is equal to, what's this here? Wow. Out of a file. Okay. Cool. I already had it there, but I have it anyway. Well, I'm going to say it's greater than 13. I should kick back in that one. 11. So I can have multiple conditions. I can keep on stacking these. Right? And just like I can do in if statements, I can group these together in parentheses, and more like mathematical operators. I can say these two. Kind of helps if I put these in the same line too. Give me where it's this, or the title is out of ectron. You should get the same results with it without those, but sometimes they do make a difference. 340. Yeah. Did I get 346 before? No, 340. Cool. Yeah. I can see that's the same general type of output. I can stack all of these logical operators and conditions, which is pretty cool. Right? Ands and ors. Right? I have all sorts of operators in here that I can choose from. You can kind of think of it as like I'm working with arrays, right? Think of this as like I'm programming against an array of data. Right? Maybe I wanted these properties. Here's my filters. Here's my criteria. Give me certain objects, right? Order sort, check to see if this value is in here. Maybe if I'm doing a string comparison, I want to lowercase or uppercase things to make sure that I don't have a letter capitalized somewhere weird. There's all sorts of good stuff I can do with queries here. And again, if I'm working on this, I want to keep on saving it. It'll tell me query saved successfully. Okay? So what I would highly recommend anybody doing, starting out in the database foundations class, pull down either SQLectron or DB browser, right? Download the Chinook database and play with it, right? Start trying to write some select queries and select through some of the tables. See what's there, see what you get. Try to select from all of the tables, right? Look through some of the navigation. Expand out all of the columns and see what you can see there. Right? Maybe discover that you can right-click on things and it'll write a select query for you. Right? A little bit of cheating, a little bit of a shortcut, but you can still do it. Right? Maybe I can right-click and make an insert statement too. Right? Ooh, did it not do that? Oh, there it is. It looks like it pasted it where my tab was. Right? These database programs are built to make your life easier. They're not there to make your life more difficult. Right? Ooh, I can view this as JSON. Oh, I can copy it as JSON. Oh, really? Cool. I know I can do that. All right. Cool, that's kind of database basics 101, right? Kind of the getting started, right? And download one of the two applications, download the Chinook database. You always have the zip file for the Chinook database. You can always re-pull that file out if anything goes wrong with it. Keep a copy of that database somewhere, maybe it's in original form. In case you're inserting data or in case it goes weird, you can always restore from a backup, right? Save and back up all your queries too. Keep all of your work that you're learning from as you write these queries. Also, when you're going to be submitting assignments, you're going to need some of these queries too, right? It gets pretty handy. Save stuff, save your work. If I close and reopen SQLectron, let me do that real quick. It's going to pop back up and it's going to look like my very first screen might open it up. Doop-a-doop. Cool. I can connect to my database. Bam, there I am, right? I don't have my query anymore though. If you close it and reopen it and you haven't saved your work, it doesn't keep it, right? It doesn't persist around. Search database objects. Cool. So I can then open my query. There it was. There's my work right there. Didn't lose anything. Cool. That, kind of in a nutshell, like I said, was my first day one databases. Install the things you need, especially for SQL. Get the sample database down and start querying against it. Like all of lesson one is just pulling data out of this system, right? Write some queries. As well, I would do the lesson one hands-on. And then it'll be pretty fun, actually. Databases are actually pretty cool. I would kind of enjoy and play around with lesson one because it will get more difficult from there. Right? But get used to how this application and how these systems work. Get used to typing out some queries. Even if you type out bad queries, right? Don't type things perfectly. You don't need to. It'll kind of give you some error messages. The title, you'll forgot something. Maybe I'm looking for the title out of E. Oop. And execute this, and it won't give me that one because I didn't spell the name right. Don't get 11 anymore. Worst case scenario, your database goes wonky, re-download it, delete your old one, put the file back in, right? As long as you keep your queries. It's cool. I wanted to keep this first one short and simple, right? Kind of a first primer on database foundations, how to get started and how to download the software you need. And it should be pretty straightforward. Right? If there are any problems or difficulties, support places are always our full stack web channel, or our mentors, or myself. Right? Reach out to me if you have questions or problems. I'll see what I can do. Can't hurt. I'm working with databases for quite a while. There's probably not anything I can't fix, right? As well with our mentors or your fellow students. Right? If you're going through this class and you have students or fellow people in your classroom, they're probably doing the same thing, or they might have the same problems. All right, cool. Keeping this one short, intro to databases. I'll upload this as soon as it finishes the cloud recording system, and then I'll put it up on our databases channel. Great. All right, I'm not quite sure what my next videos on databases are going to be. I'm going to kind of compile that and get a schedule out for everybody, but I will see everybody soon. All right, have a good evening.